Hello everyone, welcome to the introduction of natural language processing. Let's enter into NLP. First of all, what is natural language processing? What comes into your mind when you think about natural language processing? So let's just divide the term natural language and processing. So whenever we humans think of natural language, speech, text, and perhaps to some extent sign language also comes into how we communicate between each other. So basically NLP is a subfield of AI that uses algorithms to understand, interpret and modify human language. And when it comes to human language, like I mentioned, there's text, speech and sign language and all these variations. Well, of course, in this course, we are going to primarily focus only on text data. So when we mention natural language processing in our course, it refers to understanding text data. Whatever as we humans understand and interpret, we want algorithms to evolve at the same level of understanding capabilities, and that's our goal with natural language processing, to make machines or computers understand and interpret natural language as good as humans. You might have already seen a lot of natural language processing applications in and around us. For example, if you take voice assistants like Alexa, Siri, Google Home, where you ask it to do something, turn off the lights or play a song, all these things are real world applications of NLP. And chatbots are another popular thing, where you might visit a website and you ask a question and sometimes automatically you are redirected to payments page or cancellation page or something like that, depending on what you're trying to ask. Chatbots respond to you and sometimes redirect you to the right page. And again, sentiment analysis is one more popular topic within NLP. For those who do not understand sentiment analysis, it's basically categorizing any text content into usually three different sentiments: positive, neutral or negative. Let's say someone is talking about a movie review on Google, they are posting about their movie reviews. You want to automatically identify the sentiment and categorize how many people are talking positively about the movie, negatively about the movie, neutral about the movie. Similarly, on Google Play Store, etc., if you have an app, similarly you can do sentiment analysis tasks on that to gauge what people are thinking about your app. Then text summarization algorithms are also very popular, where sometimes you don't want to read the whole article and you want to get an automatic summary. And another popular use case is machine translation. So for example, Google Translate, when visiting different countries, converting text or the usual used words that you speak in your language to another language, so that you can navigate easily in a new country or state, etc. All these are popular applications of NLP. So the applications are all around us and they've been there for quite some time. Only thing is that with time we get better. So let's get an overview of all the natural language processing terminology that's used. For example, let's just take the plot of the movie Batman Begins. Let's just read it. As a child in Gotham City, Bruce Wayne falls down a dry well and is attacked by a swarm of bats. So as soon as you're reading this, we humans understand that Gotham City is a place, Bruce Wayne is a person, falls down, it's a verb, and dry well is a noun. So you interpret quite a lot of things from this, that, and also is attacked by a swarm of bats, so you know that it's a negative sentiment here that's going on. Similarly, as you read, you understand and interpret many things, right? So for all these things that we humans interpret, we have come up with terminology in NLP, and we'll see them in just a second. So the first thing is named entity recognition, NER. You might have heard it, you might not have heard it, but what it simply means is that if we can identify entities, those entities could be person, time, date, organization, or location. GP stands for geopolitical entity. Essentially, it's like a location. So you can see that if you use NER algorithms in NLP, you can automatically identify Gotham City as a plane, Bruce Wayne as a person, and Mafia is an organization, and there are other person names like Alfred Pennyworth, and 14 years later is a date. So essentially, you can train your own NER algorithm while also fixing the entities that you want to identify. Here they are identifying person, geopolitical entity, organization, date, etc. as entities. But for example, let's say if you have medical text, maybe you want to identify disease, you want to identify the dosage of a particular medicine and other things. So you can create your own entities and train a named entity recognition model, and what those entities are depends quite a lot on what your use case is. And the second thing is parts of speech tagging. So essentially, as soon as you read this sentence, as a child in Gotham City, Bruce Wayne falls, you know that child is a noun, ADP in is like add position, and Gotham City is proper noun. Again, in noun you have common noun, proper noun, and other things, and you know that comma is a punctuation, false is a verb. So again, this thing comes under parts of speech tagging, POS. So NER, named entity recognition, and POS, parts of speech tagging, these are like popular acronyms that are used in NLP, and just remember these things. And the another interesting thing is coreference resolution. Well, this term sounds complex, but it essentially means identifying pronouns. What that means is, if you read this sentence, you know that Bruce Wayne is attacked by a swarm of bats, developing a fear of them. What does this pronoun them refer to? It refers to bats actually. And attending the opera, his parents, Thomas and Martha Bruce, becomes frightened. So his refers to Bruce, and again Bruce parents in front of him refers to Bruce. So all these pronouns are resolved to their original nouns. In this case, them refers to bats, his and him refers to Bruce. So essentially, if you identify what each pronoun is referring to, so what's the corresponding noun that the pronoun is referring to, that's called as coreference resolution. Nothing too complex. And let's take a small mind exercise. How do you identify the main character or the protagonist of a movie or an article? So just give a thought. Okay, let's use two things that we learned already to identify the main character. So the first thing is, given any article, first resolve all the pronouns to their original nouns. That's the first thing. Second thing is, get a counter of all the persons, that is the named entity that is tagged as person, and get a count of them. So here you see that Bruce Wayne is the protagonist, and you know that every time him occurs, you are going to replace that with Bruce Wayne as well. and you know that Bruce Wayne, maybe it occurs 10 times or 15 times in this paragraph. And so using a combination of named entity recognition where you are identifying person and also resolving the pronouns to the corresponding person, you are able to get the count of a person in an article, and most likely the person with the highest count that is mentioned in the article is the protagonist or the main character of the movie or article. Awesome. Moving ahead, keyword and key phrase extraction is also another popular NLP use case. So for example, if you're reading through this, you will easily recognize as a human that there are some keywords or key phrases in this article, like Gotham City, Bruce Wayne, and swarm of bats, drivel, opera, frightened. So keywords can come from any parts of speech, not necessarily nouns. For example, frightened, all these are not nouns, masquerading, etc. Whereas swarm of bats is actually a noun phrase. Similarly, drivel is also a noun phrase. So keyword is basically if you have only one parts of speech in that's keyword. Whereas key phrase refers to anything like noun phrase or verb phrase, where an adjective could be combined with a noun, or verb could be combined with noun to give the noun phrase or verb phrase, etc. Those are key phrases. Another popular use case of NLP is classification, automatic classification, and especially sentiment analysis. You can automatically read the sentence and you know that the sentiment of this sentence is negative. And similarly, you can do many classification tasks. For example, intent classification is another example. Let's say in chatbot, you are asking a query, and that query needs to be, the intent of the query needs to be classified so that the company can route your question to the appropriate team, whether it is sales, payments, or website development or things like that. So identifying the intent from what you ask is also another classification problem. Similarly, there are several classification tasks in NLP that you can do. Okay, moving further on, topic modeling. For example, if you just pick up the Batman Begins movie and you just start reading through it, you'll come across words like attack, bats, frightened, masquerading, and all these things. And automatically, if you're trying to think about a genre for the movie, you know that it comes under like adventure, action, or horror, etc. Right? So topic modeling essentially means if you have, let's say, a lot of documents, can you automatically cluster the documents, and can you extract the top keywords from those documents and automatically give them a label. It could be a single label or it could be multiple labels. For example, in our movie plots case, we can take, let's say, 3000 movies and automatically cluster them, and from each cluster, that is the collection of movies, extract the top keywords, verbs or nouns, either ways, and identify it into a particular genre. For example, romance might have different keywords, and from the keywords itself you can automatically identify the topics or genre, right? So that essentially is topic modeling. You have some documents, you extract some keywords, and based on those keywords you give some topic labels. Awesome. Another interesting concept in natural language processing is actually word sense disambiguation, WSD. So for example, if you take the word bat, in the first sentence, Bruce Wayne was attacked by a bat while he was walking in a cave. Here bat refers to the nocturnal mammal, the flying bat, And if you take sentence 2, a local gang attacked Bruce Wayne with a bat. Here bat refers to a club used for hitting a ball in various games, right? So the physical bat. So here the same word bat, when used in different context, has different contextual meaning, and we need to actually disambiguate this word. For example, if a given word like bat has multiple meanings, one could be a mammal, one could be a thing used to hit a ball, then depending on the sentence you need to disambiguate what's the correct sense or contextual meaning for that word. So that exactly is the problem of word sense disambiguation. For example, I'm going to this link here, WordNet. Just Google WordNet search and you can enter any word like bat or any disambiguated words. For example, even mouse. Mouse could mean computer mouse, or it could mean the animal mouse as well. So you'll get all the various senses or contextual meanings that are available. It could be in noun, verb, or adjective, etc. You see that bat has almost 10 different meanings when used in different contexts, combining nouns and verbs. Okay, moving further on, embeddings. So embeddings is a very, very interesting and special topic, because the moment we are able to convert a given word or sentence or a paragraph or the full document into a vector, that is a combination of numbers. This is an n-dimensional array. Now you can compare vectors among each other to see how close they are together or how far they are together. So you can do mathematical operations on these words or sentences or documents to find similar documents and other things, etc. So it's a very powerful concept, and word2vec is an algorithm that can take in a word or a small phrase and convert that into a vector automatically. And sentence2vec is similar. It can take a whole sentence and convert that into a vector. Usually this vector is of 360 dimensions or 768 dimensions popularly. So usually this is like an n-dimensional vector, and n could be 768 or 1024, etc. And in the higher dimensional space you can compare vectors among each other using cosine similarity and other distance metrics. And doc2vec is similar, where you can take the whole document and convert that into a vector. And embeddings, that is converting word, sentence or document into a vector, is one of the very, very fundamental and crucial aspects of NLP, and a lot of algorithms are based on this. Okay, moving further on, recommendation systems. Again, finding similar items is another popular use case of NLP. For example, if you have Batman Begins plot, you can automatically convert that into a vector, and you can convert all the movie plots into vectors again and find similar vectors, and you can get that the closest vector to Batman Begins is actually the sequel Dark Knight. So recommending similar movies, and this is a popular use of recommendation system that's based on NLP. Of course, real world recommendation systems might use quite a lot of factors, and there might be a weightage factor combining all of those into a single score. But simply put, you can build recommendation systems that are purely based on NLP when they are text-based systems, etc. And coming to text generation systems, this is also one of the very popular use case of NLP. You might have seen examples where Google Translate can convert this sentence into Spanish or any other language. So text generation systems take in input as text and generate text as output. that text could be in a different language, then that's called as translation. It could be rewritten with a different choice of words, then that's called as paraphrasing. And there are several other use cases of text generation systems beyond this. And let's get to the interesting part of language model. So what exactly is a language model? A language model is nothing but given some input sequence of words, it will predict the next word. For example, if you as a human are given this sentence and asked to fill in this, you might think about several words that could come in here, for example fear and other things. And similarly, the longer the context is, your choice of words that you can fill in becomes lesser and lesser, and you become more and more confident about filling in a particular word. Similarly, language models are just trained to predict the next word. So they are next word prediction systems. But what happens is that the longer the context is, the better the next word prediction is. And if you just recursively keep on predicting the next word, what happens is that you will form a coherent paragraph or sentence. And language models are just trained to do that, which is given some input sentence, it will extend that sentence and keep adding words continuously. And the better a language model is, the more coherent the text generated is, and you'll feel that it's almost generated by humans. And this other thing is chatbot or conversational AI. For example, if you built a moviepro.ai chatbot, I just simulated that here, and you have movie plot. From the movie plot, you can ask questions and you can automatically retrieve the answers as well using NLP. For example, if you have some documentation in your company, if people are coming onto your chatbot and asking questions, you can automatically return the correct answer. For example, how many days of refund policy do you give? And if your documentation is already there and the 14 days is the correct answer, you can just use question answering system that is as a middle layer that will answer the questions in the chatbot asked by real users with answers from your own documentation. This is also a popular use case of NLP. Quite often people say that when you are introducing NLP, you need to understand these popular terms very well, like tokenization, lemmatization, and these things that are here. But we'll take a very interesting approach, because all these things will make sense as we do projects. So instead of theoretically understanding them, we'll stumble upon them in the course as we progress naturally, and we will see what they mean. But instead of just leaving you hanging, let me just give a 30-second introduction about these topics. So tokenization. Let's say if you have text, and text is composed of words, right? So a token is the smallest division of the text, if you want to call. Sometimes it could be word, or sometimes it could be even sub-word. So not necessarily tokens means words. For example, if you have a word like swimming, it could be divided into swim plus ing. In that case, swim is the token. So depending on your use case, tokens are just words, or they could be even subdivided from the words as well. Lemmatization is essentially converting words like swimming, ran, etc. into their root form. For example, swimming is swim and ran is run, etc. And stemming is again similar to lemmatization. The only difference is that lemmatization always converts to a root form that is a dictionary word, whereas stemming might just convert it into a word that doesn't exist in dictionary. Maybe it could be even shorter form of the word that's available in dictionary. And n-grams basically means if you have a sentence, for example, Ramsri is going to college, if you just take the two words Ramsri is, that's a bigram. If you take the word Ramsri, it's unigram. And if you take three words Ramsri is going, that's a trigram. So n-grams are basically combination of n sequential words that you split. And bag of words is essentially if you have a document but you do not preserve the sequence of the words that occur in the document and you just mix it up and maybe take counter or frequency of a certain word, etc. Basically a bag of words is bag of words, nothing too complex. We will kind of see it when we get to TF-IDF algorithm. Nevertheless, that's it for this section, and I'll see you in the next section.